Morning. So hello everyone and welcome to today's webinar, Choosing the Right Power Connector for Your Application. My name is David Zimmett. I'm the president of Orion Technologies, Hirose's representative in Canada since 1995. I'd like to introduce you to today's presenter, Dave Gallagher. Hello, Dave.
Good afternoon.
How you doing today?
Doing great.
So
looking forward to this.
Absolutely. So Dave graduated summa cum laude from Southern New Hampshire University with a Bachelor of Science in Business Studies in Operations and Project Management. He also holds a Data and Telecommunications Certificate from the University of Massachusetts Lowell. And Dave has been with Hirose for almost 4 years. Now, prior to beginning, we would like to ask you folks a couple of questions. And at the end of Dave's presentation, we will have a Q&A and would love to hear from you. You will also be able to download a couple of documents related to today's topic. Dave will also show us a number of samples pertaining to his presentation. And finally, when the webinar is over, we would truly appreciate your feedback about this session and future webinars. Thanks. So we're going to proceed with Dave's presentation, and then we'll get into the Q&A, the downloading of documents, and Dave can share with us some samples as well. All right, so here we go, folks.
Hello, everyone, and thank you for joining today to learn more about selecting the right power connection for your application. My name is Dave Gallagher, and I'm the North American Eastern Regional Sales Engineer for Hirose Electric USA. Today we will discuss some of the common questions related to power connector selection. I will cover internal, external, and even board-to-board power connectivity. Let's start by taking a closer look at the different sizes of connectors. Whether we're talking about micro power connectivity to tiny sensors, such as these here, or we're talking about big batteries and heavy lift motors, the basic principles will remain the same. There are some common questions that need to be asked if we are to select the right power connector. The factors that impact the selection of a power connector can usually be reduced to the following items: the current or amperage for your application, the conductor count, the voltage rating or any creepage or air gap requirements that you might have, or safety ratings regarding voltage, the environmental requirements for your applications, maybe an IP rating, the application information, maybe there's special mounting or space restrictions that you have. First, we'll start off by talking about the current flowing through the connector. Part of this is going to be related to the actual amperage of the connection, and part of it is going to be related to the wire gauge. When working with customers, I usually like to start with the wire gauge. Even though it is very important to know what the amperage is, I like to start with the wire gauge because no matter what that amperage is, the contact needs to crimp securely to the wire. So if you are using an 18 gauge wire, but are only using 1 amp worth of power, we will select the smallest connector that has support for the 18 gauge wire. This will save you both space and cost. Understanding the required current is the second half of this question. What is the peak amperage needed for the application? Are you running current over more than one contact, maybe multiple circuits? Are you dividing a higher current need across more than one contact, but it's only a single circuit? For power connectors, we need to understand that application and how that current will be distributed across the connector. If your current is running over a single contact, then this rating is simple and listed in the datasheets. However, let's say that you plan to divide a single 10 amp circuit across more than one contact. The initial thought is you only need 2 5 amp contacts, but the reality is a bit different. When current is divided, we will not know exactly what the contact resistance is at each connection point. This is not the same as drawing 2 completely independent 5 amp sources. 2 side-by-side contacts could have slightly different contact resistance values. How does this impact the rating, you ask? Well, the electrons will travel over the path of the least resistance. This means that contact A may be 60% of the power in our example, 6 amps, and contact B may only be carrying 40% or 4 amps. Suddenly that 5 amp contact that you initially selected is being pushed too hard and overheating. As that contact heats up, yes, we know that will produce a higher resistance value. But the core problem still exists, and we need to be mindful of it. We never want an overheating contact. connector and system failures become a real possibility in this situation. This brings us around to talking about the derating of connectors. Amperage ratings come from the temperature rise of the contacts and the ability of that contact and the connector to dissipate that heat out to the environment. This gets a bit complex because there are a few factors that play into the ratings. First off, most connectors are rated based on a fixed ambient temperature value of 25 C and an expected temperature rise of 30 C. A chart, like this one here that we see, is what you'll typically find with one of these connector ratings when you're looking at the power capabilities. Note the 25 C value. This can be difficult to define since not all users can keep the ambient temperature range at 25 C. So this brings up a derating curve to help out a bit. A derating curve looks at the amperage rating as the ambient temperature rises. We can see here that as the temperature in the ambient environment rises, the amperage rating for the connector will fall. If your ambient temperature rating will be higher than normal, then you'll need to consider the derating of that connector in order to accommodate that limited heat dissipation to the environment. Here we see them side by side for the same connector. The dotted line shows a safety derating applied by Hirose of 80% from the initial tested value. For most users, the standard product ratings will be fine. However, your application may push the temperature envelope or even the current rating, and if that's the case, it's always wise to dig a bit deeper. Here we can see a typical rating chart for our DF63 series board-to-wire connectors. As you can see here, there are different values depending on the contact count and the wire gauge. Hirose has already gone ahead and determined those test results and provided a guideline for that derating of the connector. Using our earlier example of a 10 amp current need over 2 contact 18 gauge wire, we can see that this DF63 is perfect. It's the right connector for you to choose. If you're in a situation where you're splitting a single higher current, maybe in a smaller connector over multiple contacts, that's when we need to consider additional derating beyond what you see in this chart. And that value could be up to 1/3 the original contact rating. Wow, we've spent a ton of time on the amperage rating, and rightfully so. It is probably the area I get the most questions on. Now let's talk about a few of the other design considerations, starting with the voltage. Voltage ratings seldom come up as an issue on power connectors, since typically when the voltage gets higher, the current ratings are also higher, resulting in a physically bigger connector, and hence a higher voltage rating. The two key values in a power connector when determining voltage is the air gap between the contacts and the creepage distance. We like to ask what the voltage is and make sure it is within the ratings of the existing target family that we've been working with you based on the previous current discussion. Honestly, I seldom have issues here, especially with the Hirose connectors. If you take a look here at this picture of the DF63 series, you'll note that there's internal walls on the connector in between each contact that drastically increase the creepage distance and the air gap as well. I occasionally have users that don't need the high current of a larger connector, but they do need a greater contact pitch due to isolation requirements. Now, if we were to go back to our DF63 samples chart that we looked at earlier, we can see here that there's a 7.92 millimeter pitch version. By taking advantage of this option, you can still keep the connector size small while increasing the pitch above 7 millimeters, which I hear all the time. Most battery applications are all at lower than or lower than 48 volts DC. When we get above 50 volts, applications may call for a finger-safe IP20 requirement, when the circuit being used must remain energized during connector usage. What this means is the operator's fingers are protected from accidental exposure to high voltage contacts. The definition typically comes from IEC 61984 or UL 1977, and the requirements are based on a finger probe that will be used for both a mated connection and when the connections are in an unmated state. NFPA 70E, along with several other standards, have requirements with regards to finger-safe installation, so make sure you have a clear picture of which standards apply for your application. For a product such as the Hirose DF60 series with an AC/DC 600 volt rating, a finger-safe rating may be important for your application, especially if those contacts are exposed to the user. Here we can see an example of a probe. and how that probe may interact with the connector. We must consider all access areas, including these at the back of the connector where the wires enter the housing. Earlier, we discussed the ambient temperature as a part of the current ratings. Now let's touch briefly on another area of environmental concern, and that is the IP rating. Yes, power connectors are available with an IP seal option. All of the same parameters apply with regards to the voltage and current ratings. We just need to understand what that environment will be. Here we can see an example of the different IP ratings, all in a big chart here. When folks say that they're looking for an outdoor connector, they are typically referring down the bottom here to IP67 or IP68 requirement. But don't discount the other options. Just because a connector or device is rated to IP67 does not mean it passes IP66 water jet testing. Since IP ratings are an extensive conversation, we're just going to leave it at this chart for your reference right now. If you have more questions, talk to us about your application, and we will work with you to find the best connector option. With all that we have covered today, there is one last thing I want to mention about connector ratings before I move on to board-to-board power, and that is crimp quality. Regardless of the ratings listed on a datasheet or technical specification, if that crimp is not done right, the connector will not support the rated current that you expect. There is an amazing amount of technology in what seems to be a simple crimp connection. Here we see an example of what can go wrong with one of these things when working with higher current values. Crimp quality starts off with selecting the right wire and contact combination. The insulation thickness, diameter, and material can be critical to getting the right results from your crimp. This burned out connector was a result of the wrong wire gauge, incorrect insulation thickness, and a poor crimp, all combined together. These three things could have resulted in a fire. As you can see in this picture, it wasn't very good. So choose wisely. As discussed in detail earlier, a properly sized contact will handle the required current within your application. However, it must be paired with the correct wire. If the insulation is too thin or too thick, the contact may not crimp properly. Here we can see a series of images showing common crimp issues and when you're reviewing a cross section on those connectors. This last image, this one here, this is of a good quality crimp. And what you can note here is the even shape of the contact body, and you can also see that the conductor strands are all compressed together properly. Air gaps are minimized, and the material is evenly dispersed within the crimp. Crimp tool plays a critical role in the making of this contact and getting it right, making all of this happen. Hirose offers a line of both hand tools and applicators for usage with our contacts. We also have partners both in tool making and cable termination that we work with. A list of these can be found on our website. We even have a loaner tool program for engineers to crimp contacts during the design and development phase of a project. Using the right tool will allow the full potential of a contact and connector combination. Fewer damaged contacts also means higher production throughput, which helps with the total cost of manufacturing. Finally, I want to mention board-to-board connectivity as it relates to power connections. Traditionally, these connections were either data or power, but not both. Designers would combine contacts together and when they needed to deliver more current than just what a single contact could handle. Today's board-to-board connectors offer many choices for combining power and data into a single connection. This improvement allows you to gain space savings and reduce complexity in your design by only using 1 or 2 power contacts instead of 10 or more. By taking advantage of structural space at the ends of the connector body, we have added power contacts to support significantly more current than the data contacts ever did. With products getting smaller, budgets tightening, the option to combine these two systems together solves both space and cost issues. We still have an excellent set of options for power-only contacts, so again, this is where talking to us about your application might help you narrow down the focus and get the best possible option within your design needs. Hirose's expertise in connector design allows us to both miniaturize the physical envelope and improve the electrical properties concurrently. We have covered lots of information today, and I hope this session has helped you understand the key pieces of information needed to select a power connector for your next application. As always, the teams at Hirose, and Orion are available to assist you for your next connector project. Thank you for your time. Have a great day.
I'm going to proceed now with letting you download a couple of documents. These documents are related to a number of families Hirose offers for mostly cable to board or inline cable to cable type applications. And maybe David, you want to just elaborate a little bit about what these series are. So the first one we're going to let you download, folks, is the Enerby series.
Sure. Great. Thanks, David. The NRB series is the Hirose's larger type of power products. If you're talking about values, we'll say above that 15 amp range is typically where we see our NRB family come into play. And Hirose has products all the way up to 400 plus amps. So keep us in mind for those big battery, big applications.
Okay, thanks. The next one is the Snap B series.
Snappy. Awesome. This is small stuff. So it's kind of the complete opposite here. We're talking about small micro battery power. Actually, honestly, things like small sensors also use this type of connector, but mostly small batteries.
Okay. And finally, the Signal B.
Signal B is kind of in between both of those. Typically, I'm seeing things like motor control. I'm seeing signal processing, CAN bus, very simple type of data or simple voltages.
Gotcha.
Pitches in the 1-2 millimeter range, pretty standard.
Okay, thank you. And David, I believe you have maybe a couple of samples or some
Sure.
data you want to share with us?
Yeah, absolutely. So I wanted to take an opportunity. We mentioned some of the power, and sometimes when you're looking at a screen, you don't really get the idea of the size of a particular product. So I just wanted to, hold this up here and show you this. This is that DF60 series that we showed within the video, talking about the contacts. And this thing here handles 8-gauge wire. And you don't usually see that too often when we're working with connectors. When you get up to that 8-gauge size, there's not a lot of options for cabling. But when you look at the contact pictures that I'd shown during the video, we spend a ton of time talking about making these crimps just right. And so that's what it's all about. And when you're working with a connector, you want that contact to have very good quality crimp. And it helps make the shape of it's right, so it aligns properly. The connector goes together easier. I've seen cases where there's failures because the back of the crimp isn't done correctly. And so as a result, when they go to put the connector together, it doesn't seat down properly. So keep that in mind when you're working with the connection. If you don't get that crimp right, you might not get a complete snap in on the connector. And you can I'm hoping you can hear that.
Oh, yeah.
So we have all kinds of sizes of products, whether we're talking about vertical type orientations or we're talking about right angle. This one here in particular, I wanted to show you because this has, you notice a different color here, and we have the red color. This is keyed, so I can't put the white connector into the red color or into the black one down the bottom here, but it goes very easily into the right port. So this is a great way to prevent somebody from accidentally plugging the cable assembly into the wrong power connector.
What
great
series?
if you have multiple motors.
What series?
Sorry,
is
this
that?
is the DF22 series.
Gotcha. Okay.
And let me just take advantage of this opportunity, Dave. I just want to mention, Hirose has this connector selector. This is a great tool. This is a book, and I know these days we're not getting out to visit everybody, so you can actually get a digital version of this thing. David Zimmet and the rest of the Orion team, they actually have this link, and they'll share it with you, and you can actually see all of this information digitally.
And for our French participants, this catalog is actually available in French as well.
Yes, it is.
Okay, great. Anything else you want to show us?
I was actually gonna, if you don't mind, I would like to just point out. I think you mentioned earlier there was a couple of folks that mentioned they have smaller connectors. So if you don't mind, I thought I would just take a moment and show you some smaller power connectors. Here, let me move this up so you can see it full screen here. So when you're looking at a product like this one here, this is a micro board-to-board power, and we're seeing more and more demand. And I think during the Q&A at the beginning, you mentioned some folks were looking at small board-to-board, delivering power and signal. This type of product is very strong at Hirose. We have all kinds of options as far as pin counts and amount of power, but typically we're seeing power ranges 2 contacts, 3 amps or so. That's pretty common for us on this series. And we also have versions of this that are a little bit bigger as far as pin count size. So you can, certainly see a variety of choices. But the key thing here is taking all of those pins that you normally devote just for power and moving that over to dedicated power contacts out on the outer edge of the connector, away from your data contacts, and you can run high-speed data up through the center of this thing. We're talking USB 3.1 Gen 2 10 gigabit speeds through the center line of this connector. And yet we're still delivering up to 3 amps of power per pin on the outside. This is a really cool option. When we're looking at the total scope of, say, robotic systems, and I say robotics, what I got here on the screen, let me say there's many different types of products that have huge variety of connectivity, and robotics is certainly one of them. But we have power connectors, we have data connectors, we have optical systems, we have high speed, we have low speed. It's all built in. This slide shows that it's really busy, but there's a lot of connectivity opportunity in there that we can help solve on your projects. And our hope is that when you run into this, realize you can come to us for one stop for you, and we can solve many different types of connectivity challenges.
Yeah, and I would add that we actually have this type of information available for, name the application. We have similar slides available to show you how we can assist you with your interconnect needs.
Yeah.
Thanks, Dave. So we actually had a first question, and I'm pretty sure we've answered. We'll ask the person who's asked the question. The question was, I'm interested in sub 1 millimeter range power or power and signal connectors, the hybrids. You just showed us that BM series of connectors.
Sure. Yeah.
So the answer is yes. We do have these types of solutions to offer.
Yes, we definitely do. We have, and we're talking about sub single millimeter range. We have 0.9 millimeter stack height. So if you got small control boards going together and you need power and data, absolutely, real strong for us.
Right. Okay. Next question: does Hirose offer automotive rated power connectors?
Yes, we do, actually. So it's a great option. A great question. Thank you. We have at Hirose, we actually have an entire automotive division. So we kind of break up products, industrial, consumery type stuff, and then we have automotive. It's an entire division. We have an entire product line. I didn't grab a slide for that, but I'll tell you, with automotive power, typically folks are looking for higher temperature ratings on the connectors, 105, 125C. We certainly understand that environment. Vibration, shock, those are all big concerns of automotive connectors. That's why it's kind of handled as a separate product line, but you're still talking to the same team. So you're still working with one company, and you can solve all those connector issues.
Great, thank you. All right, folks, any other questions? You've done such a good job that nobody has any more questions for you, Dave.
Oh, there's got to be one left in there someplace.
Well, actually, here's a couple of more questions to challenge you. The next question is, what about lighting class 2?
Lighting. So class 2 are our low voltage lighting. We certainly do. That would be kind of in our signal B type of products. So for anybody else, when we're talking about low voltage lighting class 2 type products, sometimes there are different ratings as far as whether or not you can put it in. It has to be inside of a box or on the outside of a box. So we certainly do have low voltage rated products. We actually have, I think, actually, David, this would be a great opportunity if we could share our LED lighting brochures that we have available. I think you have those in your listing. LED lighting is a great application for us. We have lots of options. You're getting into smaller connectors, things maybe the size of this here. Boy, I tell you, in LED lighting, this is, I gotta show this. Sorry, David, but this is a inline connector used in LED lighting, has an IP67 rating. So there's actually a gasket seal on the inside of the connector and even between the contacts. And it is used in low voltage applications, typically a couple of amps. I have a couple of LED lighting customers that are using this outdoor in a truck mount type application. So it's a great little product for that.
Okay, and that gentleman, I just answered him. And go ahead and please contact me directly. I've given you my email, and I'll share with you the Hirose lighting connector offering.
Yeah,
next question.
That's a great one.
Do you offer a resource to compare Hirose's range of products to compare amperage and signal capacity?
Oh, that's awesome. So yeah, actually we do. On the Hirose website, there is a section for category, and we have a wire to board choice there. And in that wire to board, we have this cool little chart. And man, I wish I had this handy, but this cool little chart on the website, you can actually click on the, say, the wire gauge that you're working with, and it will take you out to the family of product, and it actually shows you the different families and mixed in. It's sorted by wire gauge, wire pitch, and current. So there's actually two charts within the same thing. You go to the Hirose website, you click on applications at the top, and from there you can see wire to board in there. Go ahead and click on that. That'll take you right in there. Signal B is actually the family that we usually see that question brought up with the most. So it's right under the Signal B section. Gotcha. Great question. Yeah.
Thanks.
Awesome tool. I use that in training all the time. I didn't do that for this.
Yeah, we also have these variation charts available as well that are updated on a regular basis, right? Which will also give us all this information from, pitch, gauge, number of positions, voltages, etc.
Oh, and let me mention that connector selector, whether you're talking about the digital or the paper version of it, this is sorted by size. So when you're working on a project and you have that link for the digital version of this, it's actually sorted by size. So as you go up through, the wire gauge information is listed in the digital version of this. The pitch is listed, the voltage is listed, pin counts, all of that's actually in both the paper version and the electronic version of the connector selector. So great tool.
Okay. I don't see any more questions, so I think we'll stop here, Dave. I truly appreciate your time. Great presentation. Thank you very much, Hirose Electric, for your participation to our webinars. And folks, I remind you, we would truly appreciate your feedback about today's webinar. We'd love your input about what subjects we should cover into the future. So please take a couple of minutes. I think there's only 5 questions, and provide us with this feedback. We thank you very much for your attendance today, and we wish you a great day. Thanks again, David.